Hello students, welcome back. Let's discuss yet another super important topic for your 10th grade under 15 minutes, just 15 minutes. So let's get started. Welcome to the class. You're seeing Diksha Vedantu English for 9th and 10th. I'm your chemistry master teacher Ankitha. We are going to discuss metallurgy today. This is from your third chapter, metals and non-metals. So let's get started. So in order to know more, in order to see these kind of videos, please do subscribe to the channel and turn on the notifications. And also, not to forget, we have a Telegram channel. So please do join Diksha Vedantu English Telegram channel. The link will be in the description and you'll get free notes, assignments as well as daily updates. So yeah, metallurgy. So what is metallurgy? It is the branch of science which deals with the extraction of metals. It is called metallurgy. So what is metallurgy? It is a branch of science which deals with the extraction of metals. So where do we find metals? In earth crust. So an element may combine with a variety of other elements to make myriad minerals, but out of them only a few are variable sources, okay, of that metal. And what are minerals? So these are naturally occurring substances containing metals. These are nothing but metals. And what are ores? So ores are the minerals from which metals can be extracted economically as well as conveniently. So extraction process should be easy, should be simple, and it should be very economical, cheap, right? So all ores are minerals, okay, but not all minerals are ores. So ores are those minerals from which metals can be extracted economically as well as conveniently. So moving on to the reactivity series, you might be wondering why is this importance. So extraction process depend upon the type of metal. Okay, it depends upon the reactivity of the metals. So for potassium, sodium, calcium, magnesium, aluminium. So these are metals with high reactivity. A different kind of technique is employed in order to extract these metals from their ores. So metals with medium reactivity like zinc, iron, lead. So different kind of method is employed, different process is employed. And metals with least reactivity, copper, mercury, silver, gold, platinum. So there are different kinds of methods that are involved here. Let's see which kind of methods. First, three basic steps that we need to know while we are extracting a metal. First thing first, concentration or enrichment of ore. So what is this? Concentration or enrichment. So we will be removing all the impurities. Impurities are also called gangue, such as sand, mica, soil, limestone, etc. This is nothing but concentration process. Next one is extraction of metals. What is extraction? It is nothing but reduction of metal oxides, salts and carbonates to metal. Okay, we'll be reducing the metal salt or metal ore. Next, refining to obtain purest form of the metal. Even after extraction of metal, the obtained metal won't be 100% pure. So we will conduct the refining process just like we conduct petroleum refining, right? Like that. So we are going to refine the metal in order to get the purest form of the metal. Moving on to the very first series, least reactive metals. In the reactivity series, in the bottom we have least reactive metals like silver and gold. So they occur in their native or pure form. Why? They are very less reactive. Okay, they do not combine with other substances. And less reactive metals, copper and mercury. So how are we going to obtain this? So we are going to conduct two processes here. Okay, so not two process, I would say. So we are going to just heat the ore in presence of oxygen. Okay, we'll get oxide of the respective metal. Or if it is a sulfide ore, so we'll be conducting a process called roasting. If it is carbonated or hydrated ore, we are going to conduct the process of calcination. So this is an example. Here mercuric sulfide is made to react with oxygen to give 2HgO plus SO2. So this HgO, mercuric oxide, is reduced. So we'll be heating this and we'll get the respective metal. Same here also. So copper sulfide. So it is going to react with oxygen to form 2Cu2O, copper oxide. And copper oxide is made to react with Cu2S again and we'll get 6Cu. Okay, so this is how we extract copper as well as mercury. Moving on to the next type. So moderately reactive metals, zinc, iron, lead. So Here we conduct roasting as well as calcination. Roasting is nothing but heating the sulfide ore. Heating the sulfide ore in excess of oxygen. In excess of oxygen. This is nothing but roasting. Okay, calcination is nothing but heating the ore in absence or limited supply of oxygen. Heating the ore. So it is usually conducted for carbonated or hydrated ore. So heating the carbonated or hydrated ore in absence or limited supply of oxygen. In limited supply of oxygen. So in both the case we are going to get the respective metal oxide. So this metal oxide will be reduced using a reducing agent. Just heating is not enough. It is not sufficient. So we'll make use of a reducing agent. Usually coke is used as a reducing agent because it is inexpensive and very effective. We can also use hydrogen. Okay, hydrogen can be used as reducing agent. Carbon monoxide can also be used as reducing agent. And then we have highly reactive metals. So highly reactive metals, they cannot be reduced by reducing agents as they have very high affinity towards halogens and oxygen. Okay, so here we will make use of reducing agent because heating is not enough. Here in highly reactive metals like sodium, calcium, aluminium, magnesium, we cannot use reducing agents. Okay, they are not enough. So we are going to conduct electrolytic reduction. So here we are going to take two electrodes. One is cathode and another one is anode. Okay, at cathode what is going to happen? Reduction is going to happen. At anode, oxidation is going to happen. So cathode is the negative electrode, anode is the positive electrode. Okay, so molten metal salt is taken here. Molten metal salt. For example, if we are taking NaCl here, NaCl is an ionic compound. This is something that we have discussed in the same chapter. So NaCl is an ionic compound. We are going to melt NaCl. Okay, we are going to melt NaCl and take it. So here, if we take NaCl, so at cathode, sodium metal is reduced and at anode, chlorine gas is released. At anode, chlorine gas is released. This is about reduction of highly reactive metals. It is called electrolytic reduction because we will be passing electricity through the molten salt. Next, so aluminothermy process can also be employed for certain metals like manganese. Manganese oxide can be reduced using aluminium. So aluminium is more reactive. Aluminium is placed above manganese in the reactivity series. So aluminium can displace manganese from the respective ore. So this is called aluminothermy process. What is it called? Aluminothermy. So heating in presence of aluminium. Okay, so this is also a displacement reaction. This is a displacement reaction because the more reactive metal, aluminium is going to displace the less reactive metal, and we will be getting Al2O3 and heat and molten metal. Why molten? Because it is highly exothermic in nature. These reactions are highly exothermic in nature, so the obtained metal will be in its molten state. And then we have Fe2O3, iron oxide. So this is called thermite reaction. Thermite reaction. This reaction is used in welding of railway tracks because a lot of heat energy is released. Okay, so it is used in welding of railway tracks. Railway tracks. So we'll take Fe2O3 and it will be made to react with aluminium. We'll be heating it and 2Fe, Al2O3 and a lot of heat energy is given out. This is nothing but thermite reaction. So these processes come under aluminothermy process. Okay, both of these. So moving on, refining. So enrichment can be done in several ways. Okay, concentration, which is not in your syllabus. You will be learning about that in your higher grades. But so refining is there and also reduction is there. Okay, and that extraction depends solely upon the reactivity of the respective metals. We need to remember the reactivity series. Alright, so refining, it is nothing but the process of removing impurities to obtain purest form of the metal is called refining. 99.9% pure metal will be obtained after refining. Okay, so we will conduct electrolytic refining process in order to refine the metals. So here also we are going to pass electricity, but it is quite different from electrolytic reduction. So here what are we going to take? For example, we are refining copper. We are refining copper. Okay, so impure metal is taken as the anode. So impure metal So the metal which needs to be refined, that is taken as the anode, and at cathode we are going to take the pure metal. As always, at cathode reduction is going to happen, and at anode, as always, oxidation is going to happen. Oxidation is going to happen. And here we are going to take an electrolyte. Okay, so here we are going to take an electrolyte. So what will be taken as the electrolyte? The respective salt solution is taken as the electrolyte. Okay, so copper sulfate will be we'll be taking copper sulfate in acid as the electrolyte. Electrolyte is something which gives ions, which gives electrons, so that electrical conduction is carried out. Okay, so this is about electrolyte. What is going to happen? The impure anode, the impure metal, what is it going to happen? So from here it is going to release Cu2 plus ions in the electrolyte, and there are Cu2 plus ions already in the electrolyte, right? That Cu plus is going to deposit on the cathode. So the size of the cathode increases. Size of the cathode increases. On the other hand, size of the anode decreases. Okay, size of the cathode increases. On the other hand, size of the anode decreases, and the impurities will be deposited at the bottom of the anode, in the anodic side of the setup. That is called anode mud. What is it called? Anode mud. Okay, so this is about refining. Okay, so we employ various processes in order to reduce. It depends solely on the reactivity of the respective metal. Okay, highly reactive metals, electrolytic reduction. So moderately reactive metals, we are going to use calcination and roasting depending upon the ore. Calcination for carbonated and hydrated ore, roasting for sulfide ore. Roasting is nothing but heating the ore in excess of oxygen. Calcination is nothing but heating the ore in limited supply or absence of oxygen. Okay, and then for less reactive metals, for moderately reactive metals, we have to use reducing agent. Heating is not enough, we have to use reducing agent like coke, hydrogen or carbon monoxide. And then we have less reactive metals like copper and mercury. Heating is enough. Okay, so heating is enough, and we will be heating the ore in presence of oxygen, and we will convert the oxide, metal oxide into metal by reducing it. How do we reduce that? Just heating. Okay, this is something that we have discussed. And least reactive metals like platinum, gold, silver, so these occur in their native or pure form. That's it. Okay, so this is all about, what is it? This is all about metallurgy. Okay, it is a branch of science which deals with the study of extraction of metals. This is one of the most important topics. Okay, please go through this thoroughly and let me know in the comment section if you have liked it or not, and please do subscribe to the channel for more information like this. I will be talking about various topics under 15 minutes. Okay, thank you so much. Keep watching and all the best for your exam. Thank you so much.